Okay, the figure above shows the graph of f prime. So make sure I note this is f prime. Derivative of f on the closed interval -1 to 5. Here we go, x equal -1 to x equal 5. Graph of f prime has horizontal tangents at x equal 1. Right here, horizontal tangent, and x equal 3. Got it? F is twice differentiable. F of 2 equals 6. Okay. Find the x-coordinate of each point of inflection on F. So F has a point of inflection when f prime changes increase to decrease. Here we have it. 1 point for each of these. Okay, at what value of x does f have absolute minimum value on the closed interval -1 to 5? At what value of x does f attain its absolute maximum value? I'm supposed to find the min and the max. Show analysis. Okay, so I pull out this big chart from my extra golden notes. Trying to find the absolute max of f. I got to get my candidates. So the first thing here, it's always located at a critical or end point of f. Critical point of f is where f prime is equal to 0 or undefined. So the grader's first thing, he wants to see me identify where f prime, that's a prime there, is equal to 0. That's usually worth 1 point for doing that. So I'm going to do that. I need some space here, so let's copy this over. Just waiting for the copy. Maybe it didn't work. Let's go back here. Hold on, that just didn't get the copy there. Copy. There we go. So now, clear this off. Move this box up here. Let's move this over. And I'll make that a little bit smaller. There we go. Okay. So I write on my paper f prime of x is equal to 0 when x equals 1 and 4. I'll get a point for doing that. So now, I don't have to write this, but we're right here. So I've done that. And it says, if there are 3 points, in my case there are 2 points where f prime equals 0. It means there are 5 candidates. 3 plus 2. In my case it's 2 plus 2. Got my 2 candidates here, plus my 2 endpoints. So the candidates are, so basically I could write this, I don't have to, max of f and min of f. I don't have to write this red statement, but it kind of helps me organize my thinking. Must be at x equal the endpoint negative 1, 1, 4, and the last endpoint of x equal 5. Those are my 4 candidates. Okay, step 6 up here. The grader expects me to eliminate. In this case, I'm looking for the max and the min. So I'm going to have to eliminate 2 candidates. Let's see, double check the question here. We're looking for the x value where the absolute min occurs and the x value where the absolute max occurs. We don't need the actual max and min, just the x coordinate where they occur. Okay, so I've got to find a way to eliminate candidates. I can do that by words and or integrals. Since I don't have a calculator, my preference is words if I can see a good way to do it. And I look at the graph of f prime and see something right away. From x equal negative 1, we write this down. So, for starting at x equal negative 1, going all the way to x equal 4, f prime well, I guess I better go in steps here. I'm not sure how to handle that, so we'll just go in a couple of steps here. So we go to 1, f prime is negative, and starting at negative 1, no, positive 1, sorry, all the way to 4, f prime is still negative, so f is decreasing for the interval beginning at negative 1 and going all the way to 4. So f starts at some value and then f goes down all the way until we get to x equal, so from x equal negative 1 to x equal 4, f is decreasing. Then for, let's see, for the endpoint, f prime is positive, so f is increasing. Well, that means starting at x equal negative 1, f went down until we got to x equal 4. F stopped going down. Then from x equal 4 to x equal 5, f went up. I've just figured out that the lowest point on f must be at x equal 4. So I write that down. Therefore, absolute, oops, spell that right, min of f is at x equal 4. Copy this over. Okay. So I figured out, clear this off here, figured out that f has this type of appearance. F begins at some point. This is where x is equal to negative 1. We don't know the value of f at x equal negative 1. F goes down until we get to x equal 4. Actually, f does have a flat spot because f prime is equal to 0 right here. So f really begins, goes down, kind of has a flat spot, then goes down some more. This is the point, x equal 1. We don't know the value of f right there. That's f of 1. F turns and goes back up. This is the point 4, comma f of 4. So I know that the highest point on f is either f of negative 1 or f of 4. My normal thought would be to go find these two values using integrals. Back up here. So this part here was examples of using wording to eliminate some candidates, which we've done. Now we're on step 10, which is, so step 10 here, we would need to use integrals to figure out which is bigger, f of negative 1 or f of 4. Our trouble is, I have a graph of f prime, I have no equation for f prime, I have no areas shown or areas that can be calculated because it's a curve. So that's a sticking point. So this is the moment where I might move on from this problem. So far I would have earned 1 point for correctly identifying this statement here, f prime. I would have earned a second point right here for correctly finding the absolute min. And if I'm feeling stuck, I'm going to move on. But since I'm showing you how to do it, we'll keep going, of course. Somehow I've got to find, oh, I know. So here's the idea. Even though I can't find these areas, I do notice that since, when f prime is negative, all of this area would get counted negatively. The area above gets counted positively. So you can make an argument like so. Remember, whenever you integrate f prime, you are finding out how much f changes. So you could say this on your paper. You could say, let's see, from graph of f prime, the integral from negative 1 to 4 of f prime is going to be negative for sure. And we'll just call this a. Then the integral from 4 to 5 of f prime is definitely positive. We'll call that b. And a, the absolute value of a, is definitely greater than the absolute value of b. So f, not f prime, decreases more for the interval negative 1 to 4 than f increases for the interval 4 to 5. And need a new page here. Erase this. Well, we can use this in our discussion. So f goes down more from x equal -1 until x equals 4, then f goes up here. Therefore, so once I've shown that, of course, I'm on the next page. You can get rid of this. So the final statement here is, therefore, absolute max of f is at x equal -1. That would give me another point. That's 3 so far. The fourth point is for all the justification. So as always in our min-max problem, the justification is the stuff that takes the most work. If you found the two values correctly, they will give you a point for finding them. So if you find this without justification, they'll still give you the point. If you find this one without justification, they'll still give you the point. The words you would have to have, you don't need the red one. You would need all of this. The conclusion is just this finding it. And then you would also need all of this or something similar to get the justification point. So this is part B, and it was worth a total of 4 points. Okay, part C, let G, new function, defined by this formula, find equation, not slope, equation of line tangent to G. Read slow and careful again at x equal 2. So I didn't put this on the didn't bring over the golden notes for this one because we've done it so much. We've got some graph that looks like G. You're trying to find the equation of a line that is tangent to G at an x-coordinate of 2. So this is 2 comma G of 2. Got our line tangent here. And as is traditional, we try to do a better job on that one. There we go. So this is the equation y equals slope of that line multiplied by x minus a x-coordinate on the line plus the y-coordinate on the line. That's straight off your golden notes. So let's see. The slope right here, since it's the slope of G, slope at that point is G prime of 2. So I can go find G prime because here's G. So G prime of x, got to do G prime of x first, product rule. F of x multiplied by dx over dx. Again, the dx on the bottom is because the input variable of G, which is what we are taking the derivative of, is x, plus the second function, oops, other way around now, first function times the derivative of the second. So G prime of x equal to f of x, dx over dx is 1, plus x times f prime of x. Get that far, they'll give you a point. Now we got to go find G prime when x is 2. So G prime when x is 2 is going to equal f of 2. That's why I boxed this, so I wouldn't lose track of it. Plus, the x value is 2, f prime of 2. have a graph of f prime. F prime of 2 is negative 1. So g prime of 2, f of 2 was 6. F prime of 2 is negative 1. So this is going to be 4. Now I need to find, see, so I've got my g prime of 2. I need to find my g of 2, which is just this formula. So that's x being 2 multiplied by f of 2. That's going to be 2 times 6. That's 12. Oh, this is one more point right here. We're finding that g prime of 2 is 4. Now I write the equation y equals 4, parenthesis, x minus the x coordinate, which is 2, plus the y coordinate, which is 12. And that gets you the third point here. Again, you want to go straight down the page. Don't jump around like I am. So 3 points total for part C. It was 4 points total for part B. Yep. And then, so that's 7 total. And then part A was 2 points total, so 9 so far. Keep going here. Okay, let L, here's L, be the line tangent to the graph y equals x to the n. So here's x to the n at 1, 1. So that's right here. So the line is tangent right there, where n is greater than 1. Find the integral of x to the n from 0 to 1. So here's 0, here's 1. Find the integral of x to the n. So I'd be looking for this area. Trouble is that's a curve, so I can't find the area with a curve. But hey, I can use a formula. So let's see. The antiderivative of x to the n, straight off the golden notes, is x to the n plus 1 divided by n plus 1 bar 0 to 1. If I get that far, they give me 1 point. Keep going. So this would be, let's see, you plug in the 1. So you get 1 raised to the n plus 1 all over n plus 1. Subtract, plug in a 0, n plus 1 all over n plus 1. 0 to any power is just 0. 1 to any power is just 1. So this turns out to be 1 divided by n plus 1. That would give you the second point. Good question I'm thinking is, can you stop there? I have to be honest, I'm not positive, because they say that you don't have to do numeric simplification, you don't have to do algebraic simplification, so to me you could stop here and still get the point, although I'm not absolutely certain. So 2 points total for that one, 11 points total for part B. Gives you once again 27 points total for the entire test, which has been the pattern we've been following in all the practice tests, so I've kept with that pattern.